In the last couple of lectures, we have actually covered two new things. We have learned one of the concept first, that is called pre-allocation. Okay, so let's add those things here. And we also learned nested loop, nested for loop, how to write a nested for loop. With this knowledge, let's move on to our new exercise. So the exercise 3 is a three-dimensional matrix. Now, don't be afraid by the name of three dimension. Okay, it's actually very easy to create a three-dimensional matrix. Okay, let's first try to understand the concept of third dimension. Now, please pause the video and try to go through all the things that I've written here. It will, I believe, it will make things very clear. So, let me show you. So, here, so I have in this page 2. As you can see, this is our x-axis. So these are some of my elements. Okay, say for example, if you want to place 4, I can place it here. Okay, then 8, say for example, this is our 8. So this is our 9, this is our 5, and this is our 0. As you can see, when I have an array like this, I can place all the elements in this axis, in this one axis. So this is what we call a one-dimensional array. Okay, now if I have a point like, instead of going to 4, after going to 4 I want to go in the top. So say I want to go 4,8. Okay, now I need the help of another axis, that is the y-axis. So this is my point here, 4,8. Then 9,5, something like here. Okay, or 0,3, something like here. Okay, so when you have something like this two direction, okay, two axes, so that is what we call a two-dimensional array. Okay, so you can see this is actually, we call it 4 by 2 matrix. So when I have two dimension like this, so this is what we call a 2D array. Okay, or a matrix, simple matrix. Now, so what is the third dimension? Okay, now let's actually focus on that. Oh, okay, now say for example, say I have something like this. Okay, say for example, you are working in your diary or notebook, you are noting these things down. So this is something I have. Say for example, I have a 5 by 5 array like this. Okay, 5 by 5 matrix like this. Okay, let me just put it here. So I have this kind of matrix here. Now, so you are writing in your notebook. Okay, so it has some x direction. So it has some x direction and y direction. So this whole thing is our xy plane. Okay, this is our x and this is our y. Okay, so this whole thing is xy plane. Now if I do the same thing, okay, if I actually take a look at the same thing, oh sorry, now if I actually go to the next page, okay, in the next page again I can actually define the next page as x-axis and y-axis and place different elements here. Okay, so if you go to your next page in the notebook, I can create another page. So there I can also again, I can divide this page in this x plane and y plane and put some numbers here. Now think of it as your as the notebook. In your first page, the page they are in, it is a xy plane. Okay, it is a two-dimensional matrix, two-dimensional plane. If you look at your next page, it's again a two-dimensional plane. The next page also a two-dimensional plane. Now try to look at your diary, okay, from the outside and look at the pages. Okay, say for example, this is my first page, this is my second page, this is my third page, and inside all of those pages I have a xy plane. So the diary itself, a three-dimensional object. Each of the pages has xy plane, but the number of page, okay, the first page, the second page, the third page, this number is the third dimension. Okay, I do you understand my concept? Try to think of it by yourself a little bit. So what I'm saying, that say I have in first page I have a matrix like 5,5 matrix. Okay, in the next page you can also have another 5,5 matrix like this, same thing. Okay, in the next page you also have a 5 by 5 matrix like this. Okay, this is the xy plane, two-dimensional plane. But this was our first page, so I mark it as 1. This is our second page. Okay, sorry, so I mark it as 2. Okay, then this was our third page, this is mark it as 3. So again there are 4th page, 5th page like this way. So this one here this is my first dimension. Okay, this is my second dimension, x and y, and this one here is my third dimension, the number of pages. Okay, so again, if you actually consider the fourth dimension, you can also consider the fifth dimension. So think of it like this: you have one diary. Okay, each of the diary. So you have one diary. In the diary, each of the pages are two dimension, and the number of pages is the third dimension. Now you have like five diaries. Okay, you have five diaries. So you have something like this: this is your five diary, first diary. Then again you have another diary. It also has this kind of elements, number of pages, like there are 50 pages. Okay, say another diary has 60 pages, things like that, but it is another diary. Then you have another diary like this, it's stuck in your bookshelf like this way. So you can call it your first diary as first diary, then second diary, then your third diary like this. So this the number of the diary actually becomes your fourth dimension. Okay, I believe the concept is clear. So try to think of it by yourself a little bit. So when it comes to MATLAB, how do we actually represent this third dimension? Okay, that's the concern. So we actually write it, instead of writing it this way, we write it like this way. So I have a matrix like 5, 5 that you already know. The first page we like this. This is my first third dimension, 5, 5, 2. Okay, this is the in the second dimension. This is my matrix. Okay, so let's write the code in MATLAB. So I believe that will be more clear. Okay, so sorry, let's come to MATLAB. Let's create a matrix like this. Say for example, my A is a matrix of zeros of 5. Okay, something like this. So my B is equals to say ones of 5. It's a matrix of ones. Then C is equals to magic of 5. If you remember this thing, magic of 5, a matrix like this. Now my D is equals to say a spiral of 5. So I have four matrices. Each of them is a two-dimensional matrix in the xy plane. Now I want to place each of these matrices, stack these matrices on top of each other. First I have this A matrix, the next page will be this B matrix, in the third page I will write this matrix, in the fourth page I will write this matrix. So all together stacked on top of one another, I am creating a three-dimensional matrix like this way. So let's name it as mat. Okay, so mat is going to be our first dimension. So what I'm going to do is that means the first, all the rows of first one, that is the first page, is equals to A. My first page is containing this. Then let's do it again. My second page, okay, is contain the B, this one. Okay, then let's just, my third page is going to contain C, this value, and again my fourth page is going to contain our D, that was the spiral matrix like this way. So as you can see, if I write this matrix, as you can see this mat, this is my first dimension, this is my second dimension, this is my third dimension, this is my fourth dimension. If you check the size of this matrix, okay, you will see 5, 5, 4. So this was, each of the matrix has 5 rows and 5 columns, and then I have 4 additional columns, additional actually number. This is the third dimension. Okay, so and this way, like this indexing like this way, all, okay, we can actually create a three-dimensional matrix. Now, similarly, if I have a matrix like this, say if I want to create a four-dimensional matrix, mat4 of all, first is equals to this matrix, that one I just created. Okay, so this is a four-dimensional matrix. I have only created only one, so this is the fourth dimension, these are the matrix. So don't worry about the fourth dimension, just understand about this third dimension, and I believe, I hope that the concept is actually clear, how to create a three-dimensional matrix and what does it actually represent. Okay, so let's finish it.